A junior engineer sent me a message recently. They said, in essence, I know AI is becoming a part of engineering, but if I lean too much on it now, am I going to damage my own development? I think that's a great question, but it's bigger than it looks, because if we answer it badly, the risk isn't abstract. We can end up with engineers shipping code they can't explain. We can end up with leaders scaling confidence instead of competence. And we end up with teams quietly normalizing output that nobody really understands. So the real question is this. If AI is going to write more of the implementation, what should a young engineer actually learn now? And what should leaders make sure they're learning? In this video, I want to suggest a mental model for engineers and one of responsibility for leaders. In my view, one of the biggest mistakes is to confuse rituals with reasons. There's a kind of career anxiety that says, if I didn't do the old manual version of the work, I must be missing the real learning. But I don't think that's actually true. I do think you can miss the reason underneath the work though, and that part still matters enormously. Imagine your first day at the factory and that's the day they start moving from manual work to automated tools. Do you need to feel cheated that you never spent years learning exactly how to turn the wheel by hand? I don't think so. But you do need to understand tolerances, materials, failure modes, and why the safety guards are there. The ritual changes, the engineering doesn't disappear. Software is starting to feel a bit like that. Some things that used to be manual may now be produced in seconds. But the important question isn't, can the tool produce an answer? It's, do you understand what good looks like? Do you understand what could fail? Do you understand the trade-offs? And are you willing to own the result? In plain English, don't try to preserve every old ritual. Try to preserve the judgment that made those rituals useful in the first place. That is why I think younger engineers should lean into best practices, architecture, the software delivery lifecycle, operability, security, compliance, and business value. Not because those things sound senior, but because they are the layers where the human judgment compounds. That was really the heart of the reply I gave that engineer. Use AI, I said, but treat its output like a draft, not the final answer. Read it. Question it. Ask why it did it that way. Ask what the trade-offs are. Another engineer I spoke to made a useful point as well. Baby steps are good. Don't just ask an agent to carry out the work. Ask it to plan the work. Ask it to explain each step and why it's doing it that way. That matters because it turns AI into part of your learning loop rather than a substitute for one. And yes, I do think there's room for manual practice. Do the odd challenge, like advent of code. Sometimes just code for fun. Why jog to the shops instead of drive? Because it's good for you. And because it's fun. It's good for the environment too. And not every useful thing has to be the most efficient option available. Trace a bug end to end. Write something small for yourself. Refactor by hand sometimes. Not because the future belongs to manual purity. It really doesn't. But because friction can teach you where the edges are. There's a difference between reading a novel and writing one. Most literate people can do the first, fewer can do the second. AI changes that balance in an interesting way. It may help you produce a lot more text or a lot more code, but production isn't the same as judgment. And this is where the leadership layer becomes really important. Kim Scott's radical candor is useful here because it refuses a false choice. Good leaders care personally and challenge directly. In this context, this means saying to a junior engineer, yes, use the tools. No, don't switch off your brain. And if you're confused, say so early. Ask for honest feedback as well. And when you get it, receive it like the gift it is. That isn't weakness, that's professionalism. Simon Sinek is right about something really simple and something really hard. You need the confidence to say, I don't know. I love his anecdote about when he's in a meeting with executives and everyone's nodding away and he says, I don't understand. And it was only then that the rest of the attendees felt brave enough to admit that they don't understand either. Junior engineers, you have the right to say that. And leaders, you have an obligation to build a culture where people feel comfortable enough to say it. I don't understand. If leaders pretend certainty, teams will perform certainty. If leaders model curiosity, teams will have a chance to learn honestly. In plain English, Engineers need permission to ask naive questions. Leaders need the courage to reward that instead of quietly punishing it. David Marquet's work is useful for a related reason. The goal isn't to build teams that can wait for instructions. It's to build teams that think. That matters even more in an AI era. If all we do is replace junior initiative with machine output and senior approval, then we haven't built a better engineering system. We've built a faster dependency chain. Julia Garloff, she wrote a book called Scout Mindset, and that belongs in the conversation as well. The scout wants to see what actually is there, not what flatters their position, not what protects their ego. That is a really good posture for using AI. Sometimes the output is excellent. Sometimes it's a plausible nonsense, wearing a confident tone of voice. The scout mindset says, go and see, test it, interrogate it, check whether the map matches the terrain, and don't be upset if you're wrong. Be glad, because you've just learnt something new about the world. One thing I say to the youth football team that I coach is that you learn more from the matches you lose. I think engineering is a bit like that. The goal isn't to create a career where you never make mistakes. The goal is to make sure that the mistakes happen inside of guardrails. That's one of the most important jobs for senior engineers. Make sure the juniors can experiment, fail fast, pick themselves up, and learn. But do it in a way that doesn't bring the house down. There's another idea which I think is useful in this as well. A paraphrase of Darwin's ideas is, it isn't the strongest of the species who survive, but those most adaptable to change. Adaptability matters, and the hopeful part is that people are built for adaptation. The brain changes through use, repetition, and experience. So I wouldn't tell a young engineer to fear that the entire window for real learning has somehow already closed. It really hasn't. What I would say is this: don't worry too much about not having learnt exactly what engineers have over the last couple of decades. Worry about whether you are still learning what matters now. That means developing taste, what good looks like. It means developing judgment, when to trust AI, when to slow down, when to escalate, when to verify. And it means developing accountability. You own the output, even when the machine wrote the first draft. That means owning up honestly when you get it wrong. My bad. I didn't check the agent wasn't doing the scope creep thing. I'll make sure I do it next time. That is real learning. In plain English, the future engineer's leverage isn't raw code production on its own. It's abstraction, it's judgment, it's value creation, with ownership attached. This is also where Chesterton's fence matters. The basic idea is simple. If you come across a fence and you don't know why it's there, don't be too quick to tear it down. If you find a guardrail in a code base, don't knock it down because it looks inconvenient. Find out why it's there. Maybe it is legacy nonsense. Maybe it's a scar from an outage, a compliance failure, or a painful operational lesson. Or maybe it's to stop a load of cows from trampling over your garden. Reason first learning doesn't mean worshipping the fence, but it does mean understanding the fence before flattening it. And there's one more thing. Senior engineers do have experience. We can help explain failure modes, trade-offs, and patterns that are easy to miss. But we should also be honest to admit that younger engineers are going to help invent the right habits for this era. They are closer to the new tools. They are less emotionally attached to the old rituals. That can be a strength if it's combined with humility and serious learning. So if I were giving advice to my younger self, it would be this. Use the AI tools. Ask them to explain themselves. Keep learning the systems around the code. Practice some things manually, but don't turn that into a purity test. Say, I don't know sooner. Look for reasons, not rituals. And as Billy Bragg, my folk hero, said, you can borrow ideas, but you can't borrow situations. Your generation is going to have to work out some of this for itself. For leaders, the strategic implementation is straightforward. Junior developers can't be left to osmosis. You have to design for it. You have to create teams where explanation and exploration matters, where uncertainty is speakable and AI makes judgment more valuable rather than less. To me, that is the opportunity. Not to become the last engineer from the previous era, but the first really thoughtful engineer of the AI era. And I think that's a much better ambition. If you found this helpful, please let me know in the comments and check out my other videos. And if you know an engineer that this could help, please forward it on. And as always, subscribe if you want more content like this. That's it for now. See you next time.